Alright guys, I want us to look at this one, engineering drawing N2 third angle orthographic projection. This is the symbol, right? Because even without the questions, we can be able to interpret and answer the question, because this tells you that these views are given in what in third angle orthographic projection by the symbol, which means this is the front, this is the top. And if we are having this AA like this, it tells you that you are expected to draw the full sectional front view tracing the cutting plane AA. If this a cutting plane is situated like this, unless it's going like this from here, it's gonna go like this, which means it's now talking with a half sectional with a left hand in sectioning, even though it's in third angle orthographic projection. We do not talk about left. But if the hatches is like this, that's when they are saying with a half sectional with the left hand in section. But if it's just straightforward like this, it talks about a full sectional drawing, you understand? And this is your front, this is your top, according to what? To third angle orthographic projection. And again, if you check your BP cutting plane is situated in your front view, which means this BP, if it's like this, it talks about a full sectional of your right view, you understand? Because we do not have the word left here. Okay, on the next page, on the next page, there are questions. You understand? This was previous question paper, which was written on the 6th December 2023, on the topic of what? Of third angle orthographic projection. Figure 4 below shows the two views of a shaft guide. So what we are drawing here, it is a shaft guide. Draw to a scale of 2:1. So you must know the name of the scale. It's an enlargement scale, which means we are going to multiply every dimension here by 2 beside what angles. If there is any angle like 30 degrees or 60 or 45 degrees, that one you are not considering it according to a scale. So draw to a scale 2:1 in third angle orthographic projection the following views of a shaft guide. So what we are drawing a shaft guide. So 6.1, you are expected to draw a full sectional front view on a cutting plane, you see, like as I was just saying, you see. So a outside top view, no hidden details is necessary. So which means if you put your hidden details, of course they are not going to penalize you, but you'll be wasting your time. So if they said no hidden details is needed, once you put them, they will penalize you. So it is not necessary for you to draw those hidden details on your top view. So a half sectional right view on a cutting plane BP, a half sectional cutting BP with the right hand in sectioning. No hidden details is required. So let's start. So you are going to, it's going to be simple when you start with your top view. Top view as an outside top view, which means we're going to draw this top view the way you see it, you understand? Using a scale of 2:1, remember? Okay, I'll start with the diameter 30. So it's going to be diameter 60 since we are using an enlargement scale, you understand? So I am going to draw diameter 60. I open my compass to 30. I will change this diameter 30 to be radius 30, isn't it? So like this we go. Let me put it somewhere here, so I can even draw it dark. And then I have my horizontal center line. There you go. And the vertical one. Okay. So which is this one and that one, right? Then from there I can draw the diameter 12. So diameter 12, open it to 12, which is 24, isn't it? It's going to be diameter 24. If you have this type of a ruler, you just look for diameter 24, which is this one. Then there you go. This is diameter 24. Then now from here till there is going to be 100 millimeter. There is your 100 millimeter, isn't it? Why? Because of we are from here till here is 50 times 2, which is 100 millimeter, isn't it? So where your 100 millimeter ends, you can put a vertical constructional line. Then from there you see a dimension of 7 millimeter. So times 2 is going to be 14 days. Your 15, your 14 is here. And then construct it faint as well. There you go. Then once you are here, now you can, because from here till there is 10 millimeter. From here till here is 100, isn't it? So going back is 10, which means it's going to be 20. Then take it down. Once you are there, what are you gonna do now? So now let's get what this one. So from here till there is diameter 20. So it's going to be diameter 40. Do it. 40. There it is. Dark here and dark here. A1. Then once you are there, I can have it solid now here. And diameter, okay, this one is 30 millimeter, so it's going to be 30 to this side and 30 this other side. So I can easily put it at 30 like this and have a line from here at 60 to 0. There you go. Then from there I can now have this one from here, because you can see what is, you understand. So there it is, that way of favor. Again from here, there it is. So at that 10 I go down like this. I've got a supporter of 6 millimeter. So times 2 is going to be 12, which is 0 and 12. So it's straightforward till there, which is going to be something of this nature. Is there anything left here, which is this one? But let us deal with it when we now tolerated what this excuse me, this one, diameter 8, so that we just projected those lines going up. You understand? So now we can approach the what to draw the top, the front view. This was the top view. So again, okay, we've got hidden details from here till there, which is 14. So let's do it. 14 times 2, there is your 15. 14 I mark at 0 and 25, 24. Understand? This one faint for now. say, so they go in with 10 millimeter because they said 5, 5, because this one there by your front still on the same thing as this one there by your what, your top. So 5 times 2 is gives you 10 millimeter, and from there you have it hidden detail like this, like this. Okay, so now from here going down you can measure 20 millimeter. There's your 20. Have construction line there. So this one from here till there, I'll draw it solid without fear or favor. Is this one, isn't it? Is this one already? Now to go back is 50 millimeter. From here till there, the height of your front view is 50 millimeter. So times 2 is going to be 100, isn't it? So there is your 100 millimeter. So now have this one 100 millimeter. So I can just extend this one just a little bit. Understand? Then now you see that the length from here till there seems to be not given. You know what you are going to project these points down. They will give you the true length of your front view. There it goes, this one, you understand? So which means now without fear or favor I can have this one solid. This one, which one is this one, from there till there, you understand? So now I can go up now with what, with 35 from here till there to give me that center. See, 35 times 2 is going to be 75. 70, not 75. You must have your calculator by your side. There is no one is going to shout at you on that one. And 70 is here. So at that 70 I can have a smaller nyana center horizontal line like this. Then from there, this one correspond with that one, and we are told Gucci is diameter. You understand? So it will be the same dimension since it's diameter. It's this one. So even it's this one and that one. Have it like this and have it constructional. You see how long am I drawing them, because they are going to help you even when you are drawing your what now, your right view. So dark here, dark here, dark here, and dark here. You understand? So now let's see what is next. So the correction, because now we're at the front view. Let's read and understand the correction as so that whenever we are drawing, we know that there are lines that they will disappear, so we don't even draw them. So a full sectional front view of what, of cutting plate AA. So this one was cutted. Okay, this one will change dark. This one, okay, from here till here it will disappear, isn't it? So dark, it will remain. This one dark, dark, dark. Okay, yeah, it's okay. So now, which means again from here till here it will disappear. That is why we cannot even draw it here. This one from here till here it will disappear. Don't even draw it. Yes, don't even draw it. Yes, it will disappear. So now we can go down from here till here is 10 millimeter, which is going to be 20. There is a 20. Take it faint. So now from here till here I can have it solid. I can construct it solid. Is which one? Is this one from here till there. So now from here till there, what is happening? So you are going to construct this one, because from here till there is going to disappear. Construct this one vertically down. There you go. So that from here till there is now solid. So now from here till there is 16, isn't it? 16, which means from here till there is that 16. So 16 times 2, 32, isn't it? So where is your ruler? So 32, there is 32, 31, 32. You understand? 32. So you go up till it's 0. You understand? Then now construct it faint like this. So from here till there, you know which is dark, which is this one from here till there. So remember, now you can have it dark like this here. Then now this one from here till here, it will disappear, of course, and then this one it will change dark, because the hexo cut it throughout this one. So this one was before the cutting plane, this one was after the cutting plane, but this one it was cutted. So that is why it will change to solid here and solid there. That one will remain. It's not actually this one, is the other one. You understand? Now construct these ones vertically down. How? Like this. Faint. Then from here till there, without fear or favor, solid. Faint. From here till here, solid. You understand? So now to get this hole is diameter 4, isn't it? And let's firstly get its horizontal center, which is 8. From here till here is 8 times 2, 16, isn't it? So there is a 15, 16 is this one. So now I can put this type of line horizontal center. Then I draw a diameter 8. Diameter 8 is this one, because they said it's diameter 4 there, isn't it? Then times 2 is 8. So there it is. You understand? So now you can take these circumferences of this diameter 8 up, so that you have these hidden details. This one, have these ones, have this one. Understand? Till here, till there. There you go. Yeah, till there. So you are also going to take them horizontally, just like this, and then you are going to also expose this one. You understand? This one. So this one we've already iterated them. Even this one, which are like this. Okay, so now let's expose this supporter, which is this one, isn't it? So the height of it is 14 millimeter times 2 is going to be 28 millimeter. 28, which is 29, 28. So I mark at 0, construct it. Then now you join this point with that one using your 30mm ruler. There you go. So you've gotten this supporter already, you understand. So let's see now what is going to be dark. So this one is gonna change to what? To dark. So you are told what from here till there is 12mm, from here till there is 24mm, from here till there is 5mm. You understand? No, not 5, 10mm. So let's start with the 12 followed by the 24. From where? From this corner, from here. It's 12, 10, 11, 12mm. This is it. So I give it a mark there by 0. Now construct it this side. Then whereby your 12mm begins what? Begins 24mm. 25, 24mm is right here. Then from there construct it horizontally towards your right side. Now that 10mm is this one. Remember, it's what you did. So from here till there, solid without fear or favor, and then again from here, solid and solid. Let's see what is left before we begin to section our front view. This one, this one, this one. Yes, then now we can section. Can we section? Not yet, because this one was cutted AA. So from here till here, it will change dark. From here till here, it will change dark. Understand? Which is solid line here and solid line here. So then we can now section our front view. Decide to start here. There you go. Remember, we do not section on top of a solid line. Hatches, they must be equally spaced at an angle of 45 degrees, whether anti-clockwise or clockwise is up to you on this topic. There you go. There you go. This is the supporter. There you go. A1. There you go. Like this we go. So that's how you were expected to section your what? Your front view of this third angle orthographic projection engineering drawing N2. You understand? So this one is not part of your drawing. This one is dimension. This one is dimension. So it's supposed to be like this. So now your top view and your front view are complete. So now the question set a half sectional right view, view on the cutting PPU with the right hand in sectioning. So which means at this point, this one goes and this one goes, where this very first line with this very first line meet. You are going to have this type of a line at the 45 degrees, this line. So now you are going to project all the points that are behaving horizontal. There you go. This one, once they touch this line of yours, they'll go vertically down straight away. Remember that we've got some hidden details that's supposed to be here. Don't forget about them. So this is the center, the supporter, all of them. There you go. This one will go. It took it that side. This one will go. Once they touch your 45-degree line, they are expected to go vertically down. Down you go. That is why when we draw the third view, we do not record the dimension, because the dimension of your front and the top, they are going to give you everything there. So this is the center. So down you go. It's this one. There you go. There you go. There you go. Like this we go. So again, all the points there by your front view, they are supposed to be taken straight horizontally. So even this center, I can take it. This one goes. So remember that the BB is only cutting, where is it? It's here. So we draw what is being pointed by the arrows. We draw what is being pointed by the arrows. Whatever that is beyond your cutting plane, we consider it as an offcut. You understand? Where is the right hand of this front view? Is this side. Your right hand of this front view is this hand. It's not this one. You understand? So that is why these arrows are pointing this direction. And whatever that is beyond your cutting plane, we consider it as an offcut. We don't even draw it. So which means all this, even this up going support, you are going to see it. Are we together? So the hacksaw will start to cut from here till there. From here till there, it's a hole, isn't it? So from here till there, it will cut again. But remember, they said with their right hand in section. So let us start. So I'll have this one. So without a fear or favor, I'll have a solid line going like this. And another one that will go up like this. And like this. And like this. Let me see, because this one is going to appear as hidden. Let me see, did they set up? No hidden details is required on the half sectional, on the halves not in not sectioned. So no is required on the part where it is not sectioned, you see. So why am I confirming that? Because this is going to appear as hidden. Remember, they said it's a cycle. So this is it with that one, with this one, with this one. It was going to be a cycle. Who told you that it's a cycle? Remember the dimension, they said it's diameter 20, but they are saying it is not necessary for you to show that. Okay, so now I am going to have this one dark. You understand? And this one again actually dark, but let me even put it, this one the center with the right hand in sectioning. So the moment I'm putting this dark, so this is your right view of these two views. This is the right view, which is a third angle orthographic projection. So what separates right from the left on the very same view, so it's going to be the center line. Understand? This center line. So this is going to be your left hand side of your right view. This is going to be your right hand side of your right view. So what's going to be in sectioning is this one. So if I were to trace this cutting plane of yours, BP, this PP there by your what to call your top view. This hexagon of PP started to catch from here, goes. Once it reaches the center, it changes direction. It comes like this, like a birthday cake, you understand. So this side is going to remain as what? As an outside view indeed, you understand. So now I'll come to trace what? This point, which is this one. There it goes. There it goes from here. There it is. From here going down is going to be in hidden. Let me put this hidden so that you for better understanding. So again, isn't it at this point? Trace it. Once touch here, that goes from there, go vertically down. So this side is going to be solid. Understand? Solid with what? With this one, solid again. They were cutted most again. Which means what is going to be in section is only this portion and this one. You understand? So this side is going to be in hidden. Even though they said it is not necessary. But for better understanding, let me put them. You understand? So now there will be the same diameter of what? Diameter. Remember that we, even there by our left view, I mean top view, we did not put it this somewhere there, which is this one. So now you are going to see it clearly, which is diameter 8. There by your right view, isn't it? Diameter 8. This is it. Center pillar, which is this one. So this side is going to be in hidden, right? But this side is going to be solid. This is interesting, eh? So now you project them up, so that you come back to complete your top view from here till here. Hidden again from here. There you go. From here till the dark. You understand? So now we are going to see this supporter as well going up. So it will start from here till where? From here till where? You come to what? To your front view. Come to your front view, trace it. There it is. So this point, it will start, it will be till at this point, at this line is. But now the thickness of it, trace it right from your top view, isn't it? That goes, it's this one. Then from there is the second line from your center, which means it's this one. You understand? So I can have it dark from here till there. So this side again, there it is, this one, which means it's this one. So from here till up there, solid and solid. So that's how this supporter of yours is going to end. So is there anything that we are going, this one was going to be in hidden. For the sake of interest, let me draw it hidden. Draw it hidden. It's not a center, but it's hidden. So it's a cycle like this actually. If you look at it there by your top view as well as front view, it looks like it's a square. I understand. But we are told right from the dimension there by your top view that it's diameter, you understand. So you don't think that it's the square. What, this one? So it's going to be diameter, something of this nature. So any question? So let me know down there on the comment if there's anything I've left. And yes, is this one. Yes. So insert any 6 dimension and describes them equally on all the above 3 marks. Distribute them. Insert. So if they're saying insert and distribute them equally, so any 6 of your choice, and whenever you are drawing them, okay, let me do it. The video will be too long. So from here till here is 50. You can put it from here till there, and you are not going to say it's 100. You are going to take this dimension the way as they are, even though when you are now drawing from here till here, it was not 50, it was 100, isn't it? But then you are going to put them the way as you see. Bear in mind that when you go down there, you will put the projection symbol and the scale. So the marker will know where this drawing was actually drawn according to this, because this is not a question, it's a solution, isn't it? So this solution was drawn according to this. So any of your choice, you understand, any of your choice. If they're saying 6 and they're saying they must distribute them equal, which means you can put 3 here, you can put 3 here. So we do not have dimension on the right, you understand, and the projection symbol, you have to draw it. So thank you very much guys for watching. That was Mr. Nkosi. See you on the next video. Okay, don't forget to subscribe and like and share the video so that we draw together. See you on the next video. Okay.